We have the time axis, and we have the signal axis. Let's call this x of t, and that's the time. And we'll make a triangular ramp, but limited. Okay, let's just make it, and then 0, and then another one, and continues like that. And you may do one here. So it's a periodic signal. -2, -1, 0, 1, 2, 3, and the amplitude is equal 1. So is it a periodic function? Yes, a periodic function. So we can expand this signal into Fourier series. What's the first step? Well, the first step, it's better to express mathematically expression for this signal. So, and you might ask, but it's from negative infinity to positive infinity. Just pick any period and just define the function over one period. First, what is the period of this function? T. We want to talk about the period T. What is the period T? 2. Well, sorry, repeat every 2. So it's 2 seconds. So I'm going to define this function over 2 seconds. So I'm going to define from it's divided into 2 intervals, t greater than 0 less than 1 and t greater than 1 less than 2. So from 0 to 1, what is the function? The function from 0 to 1. T, that's right. That's easy. That's t. And from 1 to 2 is equal 0. All right. So we did that. We found the function. And we know that the period is equal to, and as we did last time, once you get the period, what's supposed to get? The fundamental frequency. Yes, radian. We call it omega naught. It's equal what? 2 pi over t. 2 pi over 2. The answer is pi. Radian per second. All right. So what's next? We need to find the coefficients of Fourier series. What are the coefficients? We have 3 coefficients. We have A naught, we have AK, we have BK. So that's the second step. The definition of A naught, which is DC component, is equal 1 over T, the integration over 1 period for the signal x of t dt, equal to. Now, I'm supposed to integrate from 0 to 2, but I know from 1 to 2 is equal 0. So first 1 over t, t is equal to, and then you will have 2 integration, 1 from 0 to 1, and 1 from 1 to 2. But we know that from 1 to 2, it's equal 0, so you don't have to do this integration. You do only the first part. So it will be equal to 1 over 2, the integration from 0 to 1, and the function it's already defined here is equal t. And that's it. Just you don't multiply by anything, just integrate. Will be equal to 1 over 2. What is the integration of t? T squared over 2. So you have t squared over 2, and the limit from 0 to 1. So you can say it's equal 1/4. So you can say it's equal to 1/4. And t squared, we substitute from 0 to 1. So you have 1/4. 1 squared is equal to 1 minus 0 squared equal to 1/4. So that will be the DC component. What does it mean? It means that this signal, just we have it here, it has a DC component equal to quarter. If it's voltage, it means you have 0.25 voltage in this signal. One component, still have more. Well, we finish with A naught. Next, AK. How do you find AK? It's very similar to A naught, but what's the difference? AK equal to, instead of 1 over t, 2 over t. You don't have to memorize, you have it in the formula sheet, but when you solve many problems, you will get used to it, you remember it, and then when you are in the exam, you don't have to waste time for looking for the formula. The same thing will be integrated over the period t, x of t, cosine what? K omega naught t. All right. So now let's just substitute by the values. 2 over t. T is equal to, the period is 2. X of t, it's defined. Cosine k omega naught. We found omega naught equal to pi, right? So pi t dt. So let's now simplify. 2 over 2 is equal 1. The integration should be from 0 to 2. Again, will be x of t is equal t in this period. Cosine k pi t dt. That's AK. We're not done yet. That's what I'm talking about. That's what we're going to face. You're going to face integration. So if you are in calculus class, you have t times cosine, then you do integration by parts, u, dv, you remember the stuff. I'm saving you headache, and just, I have a formula here, I'm going to write exactly as in the formula sheet. I look for something t cosine something, so that's what I have. I have the formula, the integration of t cosine bt. I'm using the same symbols that I used there. Dt equal to, see, it'll be a little bit involved. 1 over v square cosine bt plus bt sine bt. And then when you do that, then you make the substitution. So that's the formula. You have it in the formula sheet. You don't have to prove it. It's there. So how you do it? Well, now you can say that is your B. Call this B. Yes. That's when you're integrating t sine. Yeah. There's the two formula, one t integrate t cosine and t sine. Okay. So now I want to adapt it. So I'm going to use B, and B is equal now k pi, right? So I will continue with this formula that this is mine, and I will make from 0 to 1, 0 to 1. So let's substitute by t. 1 time is equal 1, 1 time is equal 0. So it'll be equal to 1 over b square cosine bt would be b1 plus bt b1. I'm putting t equal 1 here. Sine b1 should be sine b. That's the first one. Minus. I will now start to substitute by 0. Don't forget the brackets. Cosine 0, b will be 0 plus 0 times sine 0. All right. So I did it before substituting by the value of b. That's equal 0. Cosine 0 is equal 1. I don't know about that. I got to substitute by b now. But anyway, that's what we got till now. It's equal 1 over b square. I have cosine b plus b sine b minus 1. That's what I got without substituting by b. Now I'm going to substitute by b equal to k pi, as we read here. Just maybe somebody think it's divided by b. No, that's your b. All right. So I will say 1 over b square, so k pi square. Now, cosine b, cosine k pi, plus b, k pi, sine k pi minus 1. Now we'll start simplifying. What's sine k pi? K is integer. 1, 2, 3, 4. So sine pi is equal 0. Sine 2 pi is equal 0. Sine 3 pi equals 0. So always sine k pi equals 0. And I think also I put in the folio the rules when you have sine pi, sine pi over 2, cosine pi, all the things. I put it also so you can look at it and just point. But I'm trying to explain. If you face it, you want to do it, just plug some number and see. So that's always will be equal to 0, right? This sine term 0. So that's gone. So what's left? What's left? 1 over k pi square cosine k pi. I'm going to talk about it, but just one by one, minus 1. That's AK. That's the right formula. But you still can get some numerical value for different k. For example, just let's put when you have k equal 1. If k equal 1, so what is the value of this term? Just make it step by step. If you have k equal 1, so you will have this term cosine pi minus 1. Cosine pi is equal -1, right? So -1 and -1 is equal -2. Now, if you put k equal 2, you will have cosine 2 pi minus 1. Cosine 2 pi is equal 1. So 1 minus 1 is equal 0. If you go ahead and make another 2 values for k, so you have cosine 3k, that will be, oh, I'm sorry, cosine 3 pi, cosine 3 pi. So again, -1, -1, -2. So it's obvious now. When k is odd, this value is equal -0. So you can say AK equal to 1 over k pi square and -2, but you write here 4, k equal 1, 3, 5, 7, and so on. And if you can simplify it more, you say 1 over k square by square -2, 4k equal 1, 3, 5, 7, 9, and so on. You'll find the formula. It's given formula for that too. You can, I don't care, you use it or you don't use it, but to be the same. You can write -1 power k minus 1 over k square pi square. They get fancy a little bit in textbook, and they exhibit as -1 power k. If you substitute k equal 1, will be -1 power 1 is equal -1, and -1 be -2. That's it. That's it. If k is equal to, so -1 square will be +1 minus 0. Yeah, it's the same. Fancy. That's free. You want to use it? You don't use it, but this is what some way to express it. But I don't mind. Use the simple one, because you can use it and get the value at any k. That's what's important. So that's AK. So you can use the top one, the bottom one, both are right. Well, BK. What is the expression for BK? Before I go to BK, do you have any question in AK? So just its integration. Oh, it's not different than the last example, except only the integration. The other integration was really easy, constant. This time we have function of time. That's all. BK, that's the other coefficient. BK, it's equal what? 2 over t, the integration of period t, the signal x of t, but this time multiplied by sine k omega naught t dt. T is equal to 2 x of t sine k, and omega is equal, I think, pi, yes, pi t dt. Now I will perform the integration. So you will have integrate 2 over 2 is equal 1, and you integrate from 0 to 1, because from 1 to 2 is equal 0, and the function is equal t. This time you're going to multiply by sine k pi t dt. That's b of k. I will go to the formula sheet. Just be quick. And I found the formula there. the integration of t sine bt one over b square sine bt minus bt times cosine bt. That's when you are integrating the so again, that's the b, the same, doesn't change. Just I prefer to continue before substituting the b to make it simple as with last time. So I would say that I'm integrating from 0 to 1. So I will put here from 0 to 1, and I continue to do that. It will be the same process. Okay, let's just do it. I'm not going to give you the final result. So it'll be like a bracket. 1 over b square sine bracket, because you're going to put t equal 1. So you have b times 1 minus b times 1 cosine b. That's when t equal 1. That's what t equal 1. Minus when t equals 0, you have sine 0 minus b 0 cosine 0. Okay. Now, always will be nice like that, simplify. Cosine 0 is equal 1. Oh, but multiplied by 0. So be 0. Sine 0 is equal 0. Gone. We don't know about that. We got to substitute by the value of b. But first, that will be equal to 1 over b squared sine b minus b cosine b. I know b is equal to k pi. Now I'll go 1 over k pi square sine k pi minus k pi cosine k pi. So what we get? Well, sine k pi, try. Always sine integer multiplied by pi equals 0. Why? Because sine pi is equal 0, sine 2 pi equals 0, sine 3 pi. That's also this rule in the sheet that I give. So you will say that's equal to 0. So what's left? Only one term. That will be equal to 1 over k squared pi squared times negative. That's the negative k pi cosine k pi. Let's just simplify it more. Equal to k pi cancel with the square, so minus 1 over k pi. K pi. Again, k pi change. The values change. Depends on the value of k. Let's just take 3 values. 1, k equal 1. So what is the cosine? Will be cosine pi negative 1. When k equal 2, cosine 2 pi is equal positive 1. So when it's odd, is equal negative. When it's even, it's equal positive. I will just, so I just remind yourself, it's either negative 1 or positive 1. Well, so don't forget this is bk. So bk, you can write it this way. You will say when k is odd and when k is even. Simple way. When it's odd, like k equal 1, you get negative 1. So negative times negative is positive, will be equal 1 over k pi. When it's even, will be negative 1 over k pi. That's acceptable. If you write like that, acceptable. Do they do it in a fancy way? Of course. They like always to express in a closed form, just one expression. And also there on the sheet. Well, they can write like that. Let me just put it down here. bk is equal to negative 1 par k plus 1 divided by k pi. Let's see if it's working. You put k equal 1, which is odd. So it became 1 plus 1 is equal to negative 1 square be positive. Yes, positive. When you put k equal 2 plus 1, make it odd. Negative 1 power odd, make it negative. Nice. Yeah. So we got AK, BK, A0. What's next? the general formula for x of t expressed in terms of Fourier series. I will write it back again. That's x of t in general. Any signal, any periodic signal has finite energy, can be expressed in this way. A naught plus sigma from k equal 1 to infinity. The first term, ak cosine k omega naught t plus bk sine k omega naught t. That's the general expression. Now, I will do the variables here like omega naught in the same. A naught is equal, we got 1/4 plus k from 1 to infinity. If I write like that from k from 1 to infinity, so I'm not saying odd or even, I'm going to use the fancy expression that I get to you. So AK, what's AK? I'll go to AK, and that's the nice way expressed. So just let's take it. Okay, I'll put it there, just remember. So, oh, I missed many things. Let me write, I think I have it here. Yeah, I have it here. That's equal to -1 power n minus 1 over the k pi whole square. That's cosine k pi t plus bk, which is -1 power k plus 1 over k pi sine k pi t. So that's the signal. To get feeling of this signal, what does represent? I'd like to evaluate it at certain numbers of cases, like the first 3, 4 terms, and always when you're asked to find the first 4 terms. So let's just do it together. X of t will be equal to 1/4. Now you start by k equal 1. What's happened when k equal 1? Now look for the this term, the AK. What happened when k is equal 1? When you have k equal 1, it will be -1, -1 be -2, and you put k equal 1 would be pi square cosine. You still have here k equal 1, so you will have cosine pi t. All right, I go for the b. I just leave a space here. If you go for b, put k equal 1, 1 and 1, 2 would be negative, would be 1 over pi sine pi t. So I got the first term in both. Okay, let's just the second term. When k equal 2, that's just to remind you what we did. That's when k equal 1, and that's also when k equal 1. Now I will do when k equal 2. All right. So when I'm looking now for this one, when you put k equal 2 in the top, will be -1 square equal +1 minus 1 0. So you don't have for k2. So just to remind myself, I'll write 0. What about the other term, b here? Well, when you put k equal 2, 2 and 1 and 3 be negative. All right. So you have -1 over k is equal to 2 pi sine 2 pi t. Let me review this one. When you have k equal 2, that's 0. Yeah, because you have +1 minus 1, that's 0. Okay. So plus, let me take one more. But let's remember, that's k equal 2. When you have k equal 3, what you'll get in the top. K equal 3, you will have negative 2. K equal 3 pi, 3 times 3 is 9 pi square, sine 3 pi t. When I go for the other term for the sine, K is equal 3 plus 1 is equal 4 to be positive. And you have 3 pi, and you have sine 3 pi t, and so on. That's we got it when K equal 3. So that's these are the components of the signal, and obviously you can feel that every time the order of the harmonic increases, the value or the magnitude of this harmonic decreases to be not effective. Yes, the first terms. If you go, usually they go up to 7 or 9. In the lab, when you will do next week the programming, you are going to have the signal, and then you are going to decompose it into the Fourier components, and then you're going to add them together. You'll find that if you get up to 20 terms and you add them, you get this here very similar, very close to the same signal. If you got few terms, it will be a little bit different. If you got it like 100 or 200, you'll find exactly the same. So you'll feel that every time you're taking more terms, but you'll find that sometimes 10 terms is enough to represent the signal. So we don't make it to infinity actually, and very reasonable. So that's how you express the signal in general, and this signal has both sine terms and closed terms. How can, now the question is, okay, I got it. How can we get the amplitude and the phase of the signal? In other words, how can I plot the line spectrum? I want to see the magnitude of each component and its phase. So that is the objective. Because when you look at it, it's okay. It has a great value at the third harmonic, but fifth is small, so you can tell. Well, we observe here. That's the amplitude, by the way. When you look for the amplitude, if I ask if it's given to you a problem like that, sometimes I like to ask if you understand. I want just to understand how to do the analysis and decompose the signal, but I want you to understand what does it mean what you got. For example, let me ask you one question. What is the amplitude of the fundamental component? That's the question. What is the magnitude of the fundamental component? What does it mean, the fundamental component?
AK squared, BK.
The first. Well, that's very close to the right. The fundamental component, or the magnitude of the fundamental component, it's the magnitude of the component whose its frequency, the fundamental frequency. What's the fundamental frequency? Omega naught. So I go back there when we started. That's omega naught. What is that? That's the fundamental frequency. So the magnitude of fundamental component, it's the magnitude of the component whose frequency is the fundamental frequency. And the fundamental frequency is pi. So when you look at here, you'll find you got -2 over pi squared cosine pi t, and you have 1 over pi sine pi t. Can you see it? So if multiple choice, I can give you that. -2 over pi squared, or 1 over pi, or what I'm going to do now. What's happening, if you remember last lecture, we did something called compact Fourier series, which collect the components of that one frequency together and get the magnitude. And we said sine and cosine. Sine has amplitude AK, and cosine, cosine has AK and sine BK. So how we get the amplitude of the whole component? Say AK squared plus BK squared square root. Remember. So the amplitude of the fundamental component, it's the magnitude of the component that has frequency equal to what? Fundamental frequency. In this case, omega naught is equal to pi. So you got the following. So the fundamental component in this case equal to, I get the first one, -2 pi square, -2 pi square cosine pi t plus 1 over pi sine pi t. In this case, that's A1 and this B1. So you can say A1, the amplitude is equal A1 square plus B1 square root, which is equal -2 over pi square, the whole square, plus 1 over pi square. Sorry, it's only 1 over pi, the whole square, and then square root. And then you get the amplitude of the first component. If you like, can do it here. And the calculator, it's better to have complex, any calculator has complex mode in operation. So you have 4 over pi or 4. Plus 1 over square root. Okay, you can check the value. I got 0.377. You can check that. So that's the amplitude. What about the phase shift, the angle? I told you about something really good that you can. I told you to get the right angle, especially the sine. Usually the problem with the sine, many people confuse about. I told you about this formula. AK on angle phi k, you can write it like that. AK minus J BK. So if you are talking about the fundamental component, so the magnitude and the phase shift is equal A1 minus J B1. And you have A1. That's A1 minus 2 over pi square. That's A1. Minus J B1. B1 is equal 1 over pi. So that would be equal -2 over pi square minus J 1 over pi. See, now we know where is it. It's the cosine is negative and the sine is negative. If you do the unit circle, so cosine is negative, that in this direction, sine is negative, so it's in this quarter. So that's the angle. But usually if you remove the sine, you get the basic angle, which is this one. So if you remove everything, you can say that theta 1 is equal 10 minus 1, the imaginary 1 over pi divided by 2 over pi squared. Remove all signs, just get it positive. You get the fundamental one. So in this case would be equal to 10 minus 1, 1 over pi divided by, so it'll be pi squared over 2 when you divide it. So it'll be 10 minus 1 pi over 2. So we want to find the angle, its tangent equal pi over 2. So I'll say pi over 2 shift 10. That's equal to 57.5. That's not the pi, that's the theta. That's the, we call it the basic angle. So what is the real angle? It's 180 plus theta, right? So now we can write phi 1, because phi 1 you up to here up to cover this one. That's the phi is equal theta 1 plus 180, which is equal to 57.5 plus 180. That's equal to 237.5 degree. And also there's a way, because you might find to answer. That's why I'm telling you about the whole possible answer if you have multiple choice. You can look at it from the negative side. You can say it's 1 minus 180 plus theta, right? If you go from here to here, that's negative 180. And then you add the theta, then you reach here. So, or phi 1 is equal negative 180 plus theta. So you have 57.5 minus 180. You get negative 122.5 degree. Because usually they don't like to express angles more than 180 in magnitude. So if it exceeds 180, you make it from the negative side. And if it's negative exceeding negative 180, you make it the other side. That's what they like. But both answers are right.
This is off the phase shift.
For me?
This is off the phase shift.
That's the phase shift. So when I'm only showing you one component, but we are following the same rule we did last time. To find the line spectrum from trigonometric Fourier series, you got to convert it into compact. What's mean compact? You just square A, square B, square root, that's the magnitude. You find the angle by doing as I did here. For every single term, you make the table and do it like that. But I just did it for one term, you can do it to the rest. And when you sketch it, I'm going to show you, I'm going to answer a question, but then when you do the sketch, I sketch that, I calculate for every single one. Then that's what I found. You do x-axis, and this x-axis, that will be omega, the frequency. And the y-axis, if you are talking about the magnitude, that's AK. And you make another one, because line spectra consists of two, one for the frequency and one for the phase. So this one is omega and this one is omega, and here the magnitude AK and here the phase AK. We did, if you talk about omega 0, you are talking about DC. DC, it's equal quarter, if you remember, right? So you can put 0.25, for example, you can put 0.25, and then you make like a line here, and that's it. And when you go for pi, that's the omega naught. That's omega naught, it's equal pi. It was 0.38 if you round it, so it will be a little bit higher. 0.38. What about the phase for the first two? DC doesn't have phase shift. You don't do anything. It's DC. But the other one we found equal to 37.8 if you want to make it positive. So you say you make a line by the magnitude of the angle to 37.8 degree. That's at pi, which is omega naught. If you go for the 2 pi, 2 pi, we found that 2 pi, the amplitude is equal 0.16, and the phase 90 degree, and you continue. That's the way that you're going to draw. You continue each component, you find the magnitude and the phase shift. Of course, that can be done by computer, and you're going to do it in the lab of the computer to calculate the spectrum. And it's very important to look at the spectrum, see the result, and you see the magnitude and the phase shift of each component, as I said, so you can do the right design. The question that somebody want to ask question?
I have a question.
Yes.
When we do the phase shift, will we add and subtract by way this time or
You're talking about phi 1.
Yeah.
Yeah. Well, the reason is adding pi or subtracting pi, the way that you want to express. But the most important thing, you know, where is the location of the angle? When we did the location of the angle, that was like that. That's the angle. It's here. So you got two options. You can say, I'm going to calculate from 0 in the positive direction, or you are going to do it from this side and express by the negative direction. Your basic angle always acute angle. So and lies on x-axis. So that's I'm going to share it now. That's the basic angle. So if you are taking if you are adding pi to theta, the dark here one, so I'm getting the positive direction of it. If you move from the negative, that's negative pi. Or if you move negative pi, you are adding. If you move from 0 up to negative pi, you have to go back. So you add this angle. So you go back to this point. So that's true. You either add pi or subtract pi from that. That's true. Yes. But that's when, not for every angle. If it lies in the, you can say the third quarter. Yeah. Of course, there are many possibilities. If it happened in this quarter, second quarter, I can talk. Let me summarize. We have 4 possibilities for the angle. You should got this in trig course, algebra. The first one, if the angle here, that's the easy one, because both are positive. In this case, you get positive angle, and it's always less than 180. That's you don't have to add or subtract. What about if it's in the second quarter? If it's here, so you are moving up to this line. So what is that? What is your theta? If you have, that's your theta. So if you move 180 and subtract, so phi, if you call this theta, here phi is equal theta, nothing. What's mean theta? Theta time minus 1, absolute value of b over absolute value of a. You only take the positive value. It gives you theta. What's theta? Called the basic angle. Now phi, in this case, will be equal 180 minus theta, right? Because you are going the whole pi and then going back again. If it's in the third here, so you are moving, that's your theta. That's your theta. Just let's right, that's theta. So you are moving 180, you're moving pi and adding theta to it. So phi is equal 180 plus theta. And the fourth one, it will be here. So it's either you go to 2 pi and subtract, but that's hard. It's better to go from the negative side. It's just the negative of the angle. So phi is equal negative theta. That'd be easy. So actually you have 2 quarters are easy. The first and the fourth. The first you don't do anything. The fourth you just put, you flip the negative side. Now the problem with the second and the third. In the second, 180 you subtract theta from it. The third, 180 you add theta. That's all. So that's how you do the line spectrum, 2 parts. So and this example was good because it involved integration, t times sine, t and cosine, and also involved how to convert to compact Fourier series so you can do the line spectrum. So let's have special case that relax the situation and you can use the formula in a simple way. That's happened when you have symmetric signal, even or odd. And for even, let me just take an example. We'll see how we'll do it with it. That's a signal. That's the time axis. And that's the y-axis. And goes like that. It's 1 and 1, 2, 3. So 1, 2, 3, 4. Magnitude is 1. Magnitude is -1. And the question is, express the signal in terms of Fourier series. Expand the signal Fourier series. Well, now we are going to add one more question before you solve any Fourier series problem. The first thing you should look at it, check if it's even or odd before you start. Why? Because it will save time. It will save time. Because if it's even or odd, it means there is one term equals 0, an or bn. Depends on the type of symmetry. So why you go and start and make the integration and then you find z equals 0? So you can save 50% of your time if you know it's even or odd. In this one, the question is this signal even or odd or none? Odd. Why is odd? Symmetric about the origin. Yeah, that's right. Yeah. So we say since x of -t is equal -x of t, so that's odd function. So what happened when it's odd? In the sheet I give it, published in the folio, I will just read for you what's happening when it's odd. I have a table that has general form, even, odd. When it's odd, it said that A0 and AK equal 0. Oh, so you have only to do one calculation. So it saved 2/3 of time because you want to make the question for A0, for AK, for BK. Now you're not making A0, you now make AK, you only making BK. So that's the first question. Now I have to find BK. More than that, even BK, the term BK, you are not going to integrate it over the entire period. It's going to be over only half period. Well, BK, what's happening in BK in odd? Let me write the formula as it is. When it's odd, BK is equal to 4/t. Remember, it was 2/t in the general case. Over half period, not the whole period. X of t sine k omega naught t dt. That's BK. And I expect that this odd signal doesn't have NO, doesn't have EK. So when you express X of t in Fourier series, it will be only the sine term. So it will be equal sigma k from 1 to infinity BK sine k omega naught t. That's what you gain if you know if the signal is odd. Make life easy. So now I know that's odd. and I know also what is supposed to use, what format is supposed to use, then I start the process. I find the period first. What's the fundamental period here? That's, for example, if you start from 0, it will finish. So it's like 4 or 3. Let's start from, oh yeah, 4. That's right. Because start positive and then 2, 3, 4, and after that we'll continue. That's, yeah. And also you can say this is the period from 0 to 4 or from -2 to 2. You got both, right? I'd like to use this. I don't know why. I like to use them in part, since symmetric. I use part negative, part positive. So I'll say that the period of this function starts from -2 up to +2. That's the period. It doesn't make difference, but just it's like, I like it in this way. So when I split it to halves, it'll be easy. So from -2 to 2. So when I make integration, I make integration from -2 to 0, from 0 to 2. If I want to make integration over the whole period. Half period, I can just make from 0 to 2. Can do that, right? Because if the period is equal 4, so what is half period? 2, right? So it means the integration should be over 2 seconds. And 2 seconds also, I can take it from -1 to 1. I can do that, right? Okay. So let's now find BK. That's the formula. And how to implement that? We'll see BK equal to 4, but we didn't find, oh, found T. T, let's just write T is equal to 4. So 4 over 4. 4 over 4. I'm working on this. And the integration will be from 0 to 2, T over 2, not the whole thing. The function sine K, what's omega naught? Omega naught is equal to 2 pi over T. 2 pi over 4. So it'll be pi over 2, right? Okay. So pi over 2 T dt. So that's the in general. Now I will start to work on 4 by 4 is equal 1. From 0 to T over 2. T is equal 4. It means 4 over 2 is equal to. So I want to integrate from 0 to. From 0 to 2, the whole thing. Sine K pi over 2T dt. I go back to here from 0 to 2, but from 1 to 2 is equal 0. So I'll just integrate from 0 to 1, right? So I'll say that will be equal to, it's getting simple, 0 to 1. X of t, you go for x of t. What's the definition of x of t? Is equal 1. So 1 sine K pi t over 2 dt. So in the end, I want to integrate this function. Well, you always can simplify everything. You can call, I'd like to call B is equal now K pi over 2. So I will write it like 0, from 0 to 1 sine bt dt. What is the integration of sine? Or negative cosine? So be negative cosine bt over b over b, yeah. And the integration from 0 to 1. Now I'll substitute. I'll have, and we said if you have negative, so how we write positive? You change what? The limit from 0 to 1, make it from 1 to 0. It make up for the negative sign. Equal 1 over b. You put 0, so you have cosine 0 b minus cosine b1. That's what you got. What's cosine 0? 1. So the answer will be 1 over b, 1 minus cosine b. Now I will substitute by b equal to k pi over 2. That will be 2 over k pi. That's not k, 2. 1 minus cosine k pi over 2. And again, we start here. The value of k is very important. If k is equal 1, what you get? If k is equal 1, that's bk. BK will have, even you don't have to do the whole thing, just it's important just to do this part at least. What is this part equal to? If K equal 1 minus cosine pi over 2. Cosine pi over 2 equal 0, right? Cosine 90 is equal 0. So it's equal 1. When K equal 2, so you have 1 minus cosine 2 pi over 2 pi. Cosine pi will be equal negative 1, negative positive will be equal 2. Let's just, when you have fraction like that, you don't get it from 2 values. You got to make it like 4 values because it's changed. It's moving slowly, pi over 2, pi over 2, pi over 2. You have to take at least 4 values. But if something only pi, 2 pi, it's enough to take 2 values. So when K equal 3, 1 minus cosine 3 pi over 2. 3 pi over 2, that's 270. Cosine 270, again, will be equal 0, right? So it's equal 1. K equal 4. 1 minus cosine 4 over 2 be 2 pi. Cosine 2 pi is equal 1. It goes 0. So is it changing really? So you cannot just say it's equal 1 or 2, anything like that. It's 1 times 1, 2, 1 and 0. So I will just leave it as it is. And then when I need it, I evaluate it. I cannot make it and come back like minus 1 power k. I can't do that. So that's BK. Anyway, I found BK. What I'm supposed to do now? Put it in the expression of x of t. So x of t equal to, let me just write the formula here. K 1 to infinity, BK sine. It's only sine because it's odd. Sine K pi over 2t. And now we got B, K is equal to 2 over K pi, 2 over K pi, sine K pi over 2t. It's okay, any term does not have K to put it outside the sum. So 2 over pi is like constant, you put it outside, doesn't have K, and you leave the K inside, sine K pi t over 2. From K equal 1 to infinity, that will be the expression for the signal in.
Wouldn't you have to include the 1 minus cosine pi over 2 in your BK?
Oh, why? Exactly. Yeah, I forgot it. Has to be there. Has to be there. You're right. That's the magnitude and 1 still magnitude also. Cosine K pi over 2. Yeah. Sine K pi over 2t. Now I'll take 2 over pi constant, and I will leave 1 minus cosine K pi over 2 over K sine K pi over 2t. And that would be the expression and for the signal in Fourier series from K equal 1 to infinity. Remember, the fundamental component has fundamental frequency equal pi over 2. So, right, we did that before. Let me remind you. Found t is equal to 4 and omega naught 2 pi over 4, which is equal to pi over 2. So, question: what is the value of the DC component exist in this signal? Again, what is the value of the DC component in this signal? 0. That's right. See, look, some question like that very easy if you understand the physical meaning of it. Come the exam, doesn't take more than 1 second. If you understand DC component A naught, and you know A naught is equal to 0 because it's odd. Okay. What is the value or the magnitude of the fundamental component? This question becomes an exam. Because I'm not going to ask you to write this expression. This expression to ask you, I'll give you multiple choice, very similar, and you work it out and see which one matches your work. Because in the exam, you cannot write sigma and all the things. So I give you choice or ask questions like that to see if you understand the expression. So I can give you the expression. What is the value of the fundamental component? Then you got to calculate it. How you do it? I want somebody to answer. How you calculate the magnitude of the fundamental component?
For this one, would it just be the square root of B1 squared?
Square one. Can you write? I want value. When I see value, like this, real number. Do you like I give you a minute to give me that answer? That's like an exam. That's what you want to ask. And I expect that you do it in 3 minutes. By the way, if some question like that, 3 minutes. How can, the question is, how can you find fundamental component? Fundamental component, it happens when k equal what? 1. So what's supposed to do? Put k equal 1, right? So you can go the amplitude. You're unlucky. Why? Because you don't have sine and cosine term. You have only sine terms, right? The previous example was complicated. Have sine and cosine, you got to get a and b and square root. But now we have only one term. If it's only b, so the amplitude will be equal to the fundamental when k equal 1. It's equal 2 over pi, and put k equal 1 will be 1 minus cosine pi over 2 over 1. I substitute by k equal 1. If you like to write the whole term, you can write sine, but I don't care. I know it's sinusoid and with the fundamental component. So in this case, we have 2 over pi, 1 minus what's cosine pi over 2? 0. So it's 2 over pi. And then you got to find the decimal. Because you'll be in the exam, ask round your number, your answer to 2 decimal or something like that. So 2 over pi, I got here. Then usually I will ask you round the answer to 3 decimal. Let me give you the whole screen. 0.63661977 and so on. I'm asking you for a 3 decimal. So what's supposed to do? 0.637. If you make it 0.636, the exam has the final answer. We'll compare your result by the result that's there. It will mark it wrong. So you got to be precise. You can get this number right, and then when you ask 3 decimal, you don't round it, because you have to round after 3. You got to do it right. Or the final answer in the folio will make comparison between your answer and its answer will not match. Should be precise in that. So that's how. Okay. What is the phase shift? It's very simple, but sometimes people find it complicated. What's the phase shift of the fundamental component? If you know the rules that I told you about in the first example, you do to get it right. It's easy and simple. That's why some people doubt it, because really it's so simple. I'll give you half a minute. Try one. By the way, this question will be divided into 2 questions. One question in the exam, I'll ask you the amplitude, and another I'll ask you about the phase of the fundamental component. And each one doesn't take 2 minutes. Well, let me write answer, 90 degrees. Anybody has an answer? Another answer? Oh. The lecture is over. Just let me now, just solve this one and we're done. So you write it like that, A1 on angle phi 1, it should be like A1 minus JB1, right? That's the way you do it. So A1 is equal 0 because it's odd. All A's are equal 0 minus J. What's B1? B1 is just we got here. That's your B1, right? Which is 0.637. So what is the angle? Negative pi over 2, negative 90. Because positive is 0 and minus J is down. So it's minus 9 degrees. Yes.
So in the exam, if we do negative 90 or 270,
You give it negative 90 or 270, yes. Yes. But it will be, I will be precise. I will, okay, that's a good question. Both are right, but always in the spectrum, on any angle, you don't want it to be more like 180. So you can make it negative 90 or you make it 270, but you find 270 is big. So be negative. But to alleviate this confusion, to just avoid it, I'm just asking you, express the negative angle or positive angle. Yeah. Yes.
So you want, so if the general equation is like A1 minus B.
That's the one used. Yes. Yes. Yeah. And the amplitude A squared plus B squared square root. Don't use the sign. Let me just. I know I'm done. It's only half a minute. What about if you found that it's equal -5? -5. The magnitude is equal 5. The angle. No. 5. The magnitude of 5 is equal 5. And the angle is equal 0. -5, the magnitude is equal 5. The angle is equal 180. -1, it means 180. Okay. That's it. So I would put exercise so you can practice.